Hi, I'm Cesar. I work here at Charter Aerocast. I'm a metallurgical engineer, and my title is Director of Customer Service and Quality. So Charter Aerocast make castings, parts. The main business is agriculture, like tractors. We also make parts for defense, pumps and compressors. We have made for the railroad business, like axles for locomotives. Now we're going to talk about the process. Everything starts when a customer comes to Charter Aerocast and gives us a drawing and asks us to quote that part. So we have to quote to make the tooling, which is called the pattern, which is basically the first part. Then we can make molds using sand and clay and water, and then you can pour several parts per day. Everything starts on the melt department, where they're gonna charge the furnace, induction, electrical furnace. We have 10 different types of material, different chemistry. It's like you're cooking, You're gonna melt, you're gonna add a little bit of this, a little bit of that. Now the liquid iron goes to the molding line. We're gonna pour the liquid iron inside of the mold. About 3 hours later, that casting is solid, cold enough so that we can punch out and wait a little bit more before we shot blast, and then we grind. And then we can inspect and ship. So basically we can make casting one day and ship on the next day. The definition of cast iron is iron carbon alloy with more than 2% carbon. And I need to compare with steel. What's the definition of steel? Iron carbon alloy with less than 2% carbon. So most of the steels have actually 1% carbon or less. Like if you want a drill bit or a bearing that's very hard, you have about 1% carbon, and that carbon is going to create what's called carbides. Well, the cast iron, you have a lot more carbon than that, 3.4, 3.8%. That should be harder. However, it's not. So we do something that carbon is going to create what's called graphite. There are two families. One's called gray iron, one is called ductile iron. On the gray iron, the graphite has a shape like a cornflake, and the ductile iron has the shape of spheres. It's called nodular iron. So that makes a big difference, because graphite breaks easy, right? Like your pencil, you drop and it breaks the end. So gray iron is brittle. So why people going to buy gray iron if that's brittle? One is sound damping. That shape of graphite don't let the sound move too fast, so it doesn't ring. It's like a piece of wood. If you need an engine block, a brake rotor, you don't want noise, gray iron is better. And graphite is a good heat conductor. Again, brake rotor, engine block, you don't want those to heat, so gray iron is better for that. Ductile iron, you can make axles, you can make structural parts for tractors, so it's much stronger. Okay, now we're going to talk about process control, starting on the melt department. Again, cast iron, we analyze 22 elements. So the melt guys, they have a device called a thermal analysis, which they use this cup. It's a sand cup with a thermocouple. You can see two different wires. They are welded in the middle. So when you pour the liquid iron inside of that cup, this thermocouple is going to check the temperature. And the temperature, first is liquid, the temperature is going to go down, and then when the solidification starts, it actually generates a little bit of heat. So that cooling rate is going to change, and then by the time the solidification is done, the cooling rate is going to go up again. This device tells you how much carbon and silicon you have in the iron. Let's talk a little bit about chemistry. We talked about carbon and silicon, right? So these are the most important elements in the chemistry. Carbon is the one that's going to allow the graphite to solidify, and the silicon is the element that actually is going to push the carbon out of the crystalline structure. I mean, to understand what happened when the iron solidifies, you need to imagine that the iron is like a crystal. The atoms are arranged in a certain way. They have a certain size. Some are bigger, some are smaller. And that carbon is small, is in between the iron atoms. The silicon goes there and fight for that same space and push that carbon out. So the carbon now needs its own space and is going to meet with another carbon and create graphite. There are other elements that are important. For example, copper. Even though copper is a soft element, that makes the ion stronger. We run different grades. Some are softer, some are harder, stronger, and the element that we add is copper. Not much, like 0.8% would make the strongest ductile ion that we make. All right, let's talk about chemistry control. Okay, we talk about the melt department, guys, pouring that little cup that check carbon silicon. Well, we need other elements, and they're actually going to send samples to the lab. We are going to grind the samples like this, okay? And we're going to put on this equipment that's going to open an arc like when you're welding, and that light, the spectrometer is going to read 22 elements based on that light. How does that work? Well, we got to teach the spectrometer, right? So we have standards, for example, 0.2% copper. This one, 0.8% copper. If I burn these standards on the spectrometer and I tell the spectrometer, this one has 0.2, this one has 0.8, now the spectrometer knows it's going to have a curve. If the next sample has 0.5, the spectrometer is going to look at the light and tell me 0.5 copper. That's how spectrometer works, and it analyzes 22 elements for us. Well, I'm so happy that I chose to work at Charter Aerocast, where we use science every day. If you enjoy science like I do, there are many careers to consider in manufacturing.